All right, I guess it's about time to get started. Thank you all for coming. My name is James Pannacciulli. I do DevOps over at Media Temple. We're a web hosting company. So I have plenty of opportunities to use Bash every day, and I always enjoy using Bash when I can. It is the right tool for plenty of things, especially if you're doing administrative tasks, because that is the shell that you're using anyway for most of those. So go ahead and download my slides now or later. Hopefully, they'll be good enough as a reference. I'm going to go pretty fast through this talk. It's more of a tour than a tutorial, so you probably won't come away from this knowing 5 million new tricks, but you'll know the names of some of them, and you'll have seen some things perhaps explained that you were curious about, or some new things that you never knew about that you can look into later, and I hope that my slides can help be a reference for that. So a few notes about the presentation to start with is that I do assume that you're familiar with the command line. I won't be teaching you how to CD and what a directory is and all that kind of stuff. This is about Bash. It's not about all the great command line utilities that you might run from Bash, but about the things that you can do with Bash itself, because this is the glue that we're talking about, not just the ecosystem. And I'm assuming a GNU Linux machine, but obviously everything here is going to be pretty portable. There's only a few things. Like if I'm looking at PID files, that kind of stuff might change from OS to OS. And then most of it's compatible with Bash 3. A few examples require Bash 4. And honestly, these days, if you don't have Bash 4 yet, you should probably upgrade because your distribution is going to be pretty ancient. Lots of security holes, I'd bet. So I think Bash is fantastic. I enjoy my time, and I hope you enjoy your time that you spend with it. Maybe I can help. So there are several command types in Bash. The most frequent one that you'll use is a file. This is something like Firefox or ls. Right? These are external commands. They're entirely unrelated to Bash. You just happen to be using Bash to launch them. And then there are built-in commands. These are compiled in. You can actually write your own built-ins as modules if you want to get really advanced. And these have access to all of the internal variables that Bash has. So we can see with the type-a command below here, for instance, that cd is a shell built-in. CD needs to be a shell built-in because all that it does is directly manipulate the current working directory, which is a variable that Bash stores internally. No external program can set that for Bash. And then we have keywords, which are reserved syntactic words, and of course functions and aliases. This is how you can define your own commands on the fly. Aliases are super simple. They can't do much. Functions can do everything. So it depends on your usage case. We can see here that on Ubuntu 12.04, ls is aliased to ls-color=auto, right? Gives you nice colors at your command prompt. And Bash is smart enough to know not to infinitely recurse on that, right? It also knows that ls is a file, bin ls. So it actually expands that and then runs the real ls when you run that alias. Genpass is a function that happens to come with Ubuntu. That just gives you a pseudo-random password. You can give it an argument to give it a length. Things like that can be common usages of functions. Your init scripts, for example, almost always have a library of Bash functions that they use to help do everything and keep the init scripts themselves concise and easy to read. So there's lots of ways to get help. Type should be your first thing that you go to because that's going to tell you what type of command you're talking about, which informs you as to where you should get that help from. Help is what you're going to use for Bash built-ins and keywords. You can also find information about these in the Bash man page, but they won't have their own man pages, right? Something like CD doesn't have a man page. Apropos will help you find the man page you're looking for, and then, of course, man brings up the system man pages. And info is more advanced than man pages, but only certain programs have more information in info, so you just kind of have to look there sometimes if you suspect that you're missing some of the documentation. And here's some things to play around with there. So we'll get some definitions out of the way. I'm going to use these as technical terms throughout the talk. A word is a sequence of characters. So this is generally delineated by white space or a few other special characters. And list here is a command list. I'm going to use the word list, even though I recognize it could be a little confusing, just because in the Bash man page, every time they talk about a command group or something like this, or a compound command, they use the term list to represent the command list inside there. And that can be just a simple command, or it can be a sequence of pipelines. So you can get pages and pages of text could be that list, and it could be your whole function. Everything could be in there basically. A name is a word that has only alphanumeric characters and underscores and cannot begin with a numeric character, which is important because that's how we make variables. And a variable is a special type of parameter. So a parameter is an entity that stores values, and variables are user defined. You give them a name and then a value. But there's also positional and special parameters, which we'll get to. Every time you run a command in bash, it's going to give a return status that indicates whether it was a success or a failure. So success is 0, which is maybe opposite from some other languages, but this is the Unix way of doing things, right? So if it returns 0, it's success, and if it returns anything else, it was a failure. These can range from 0 to 255. They cannot be negative. The last executed command will have its return value encapsulated in the special parameter ? So that's how you can check to see the specific return value. And a lot of programs will use different values here to signal different types of failures. Right? For instance, rsync has a whole list in the man page of different return codes you can expect, depending on the type of failure you got, which is absolutely necessary if you want to script around different types of failures. Right? If you couldn't connect to the server, that's a very different problem from not being able to access a particular file in the list of files you were trying to retrieve. So your script might want to handle those differently. And instead of trying to parse an error message, you can just use the value there because that's not going to change depending on the locale or anything, right? Compound commands can do iteration, which will continuously loop over something given a certain set of conditions. It can do conditionals, which will execute the list of commands only if certain conditions are met. And you can also group commands, which is useful either kind of like in high school arithmetic where you want to do something first or something, but you can also affect redirections that way for the whole group, which we'll show in a little bit. So I'm going to go through each of these. While and until loops, right? So this is iteration. Typically, we're going to be iterating based on an external resource with these, which means that at runtime, we don't yet know how many iterations we're going to have normally. You don't have to do it this way with while loops, but that's the only type of loop that you can use to do that, right? So while list 1, so it's going to run list 1, and if that succeeds, it'll run list 2, and then it'll repeat that until list 1 fails. Until does just the opposite. It'll repeat that until list 1 succeeds. So an example of that, right, we're going to use a while read loop, and read is successful as long as it read a line, right? So as long as I didn't give it a Control-C or something to break out. So once I go into that, I can do 1, 2, and you see what it's going to do here. It's going to echo my variable 2 and then my variable 1. So it's just reversing them. Right? So with this, it's still waiting for input, right? So if I go 1, 2, 3, it gives me 2, 3, 1, which does illustrate one point about read. The last variable name that you specify for read will grab the whole rest of the line. So if you have more words than you were expecting, they get dumped in there. So if you want to make sure that you don't accidentally grab extra input when you're only expecting 2 things, you could always do something here like another yada yada or something, right? And then 1, 2, 3, I'm not even doing anything with yada yada. It's getting assigned, it has a variable there, but I'm just throwing it out inside my loop. I'm just not happening to use it, right? So then we have for and select loops, and these are going to iterate based on your command line arguments, which means that you will know how many iterations you have at runtime as soon as you know how many arguments that you have. A for loop is extremely useful. You can easily make for loops that operate on all files in a directory or something like that by using wildcards. So for name and words, we're going to assign name, which is our variable, the value of the next word in the list that we gave it, right? And then we're going to do the list of commands each time until we've exhausted all of the words. So to show that real quick, we're just going to do for I is our variable, and then we give it our list of words here, and we're just going to echo it back with some fancy business around it, right? And we can see that we only echoed 3 times because even though I said words are split by spaces, the quotes there nullify that, right? They cause that to be treated as one word, one object, the 3, 4. And we also have the C-style for loop, right, where this is basically a special case of a while loop, except that we do know how many iterations we're going to get because we're giving it math, right? It's just arithmetic expressions inside of there. We set up an initializer, a condition, and an afterthought. The initializer gets run to set our variable, and I'll show that here. Right, so I equals 0, so we're going to say we're starting at 0, and then the condition gets run, it gets checked rather, each time before the loop to see if we still meet this condition that I is less than 5. And then each time after the loop, we go ahead and increment I. So we get 0, 1, 2, 3, 4, right? We don't get 5 because once it's 5, we no longer meet the condition of being less than 5. Pretty straightforward. And we also have this select loop, which is a little bit different. This one, if we go back to the slide here, we select name and words, so it's like a for loop in that sense, in that we build our whole list of objects that we're going to iterate on from the command line. However, this one is specifically for taking user input. It gives a little menu system, basically. So it'll give them a choice, 1 through however many we have, and they'll say, oh, I want 3. It'll put the index number of the choice they chose in the reply variable, and then your variable that you named with your name there gets the value. So we can see that here. My variable is called choice. It's the user's choice. We have 3 arguments there, right? So we get a list of 3 that I can choose from. If I select 2, I'm just going to echo the reply variable and the choice variable back. So I get 2, 2, right? And same thing if I echo 3. That works just fine. It's treated as one word because it was quoted. Right, so this is a simple way to build in some kind of menu system if you need that in your function or your script, your application. Probably not great if you're running this from another script because you need a person there for it. We can test all sorts of things from Bash. This allows us to branch on different possibilities or make sure that everything's sane before we proceed. Make sure that it is a directory if we're going to remove it, or that it's not a special file, all these kinds of things, right? So we can test for emptiness or non-emptiness, equality. Since Bash 3, we have regular expression support in our tests there, which is extremely useful. And when you do a match with regular expressions, the parts that you match actually get pulled out into an array as well, so you can kind of use back references that way too for later processing. The old way of doing it is a single bracket, and that's either a built-in or a file command. The new way is a double bracket, which is a keyword, which actually means that there's a certain level of word splitting that's not performed, which helps avoid certain types of messy quoting issues and stuff if you have things in variables. So that's kind of nice. And we also get this nice pattern matching effect, where if the right-hand side of an equality comparison is not quoted, it's treated as a pattern, and if it is quoted, it's just a literal string. So when I say pattern, it's not a regular expression there. That's actually the same kind of pattern matching that you use in globbing. So if you've ever ls star.text, something like that, that star is that's the same kind of pattern. One of the ones that I want to point out here, given that we were just looking at our select menu, is -t. Right? That tells us if the input that we're working with is actually coming from a terminal. So if you want to know if this is an automated process, a script that's running you, versus somebody sitting at a keyboard, pretty important if you're thinking about putting a menu system in there. We can just do -t0. 0 is stdin, standard input. Right? And that doesn't look like anything, but here in my prompt, actually, I have the special variable that encodes the return value. This guy, right? So that's 0, that means success. So I could put this in some kind of conditional statement to branch on that. And to show what happens if I actually have a case where we're not taking input from the keyboard. So here I'm redirecting input directly from a file. We get a 1 here, right? So it fails. So we can see how it detects whether or not I'm actually a human or if there's input coming from anything else. If then else phi, right? So in Bash, we want to always terminate our if clause with an fi. That's an easy way to do all sorts of complicated branching because you can put as many else or elifs in the middle as you want. It doesn't matter whether you say else if or elif, by the way. But yeah, so you can do all sorts of complicated things if you need to there. And that works just like you would expect, right? We have if A is A, then yep. If not, nope. Yep, A is A. Not surprising. If A is B, Also not surprising that A is not B. And a little bit more about the pattern matching, right? So this is used in the double brackets, in the case keyword, in pathname expansion, which is globbing, and in parameter expansion, which we'll get to in a little bit. So star is any string including null. Question is any single character. And we can also do character classes inside brackets. And this matches any of the characters enclosed in there, with some special cases at the bottom of negating that entire class, or doing a range, or using some predefined classes, which are, for the most part, self-explanatory. Alnum is alphanumeric, right? Digit is numbers. So with that, we can easily build out scripts that match certain types of characters without having to specify all of them ourselves. And case is a great way if you actually just want to match a string or a variable against a bunch of patterns. Instead of writing a whole bunch of tests with the double brackets, case kind of helps consolidate that for you. So you put your word or your string there that represents a word up top, and then for each pattern, you can perform the actions described in list if it matches that pattern. So as soon as you hit a match, it runs list and it exits. There are some recent additions that allow you to do some more complex branching there, but this is the general case. So if we want to see that in action, case 1. So 1 here is not a variable. 1 is just a string, O-N-E. Right? So is that going to match O? Is it going to match O star or just star? Right? So in this case, star would be a catch-all. If it doesn't match anything else, it's got to match star. What do we get? We get O star. Right? Why? O is in 1, but it's not exhaustive. The pattern needs to fully match. So you need that star on the side to say O followed by any number of stuff. Right? And that's what we get there exactly. Command groups, like I said, they allow you to group different things, and there's two ways we can do it. The first is with a subshell that actually launches a new instance of bash, right? So it has its own environment, its parameters are contained. Basically, all of its variables are scoped locally. So any variables you set inside a subshell, they're gone completely once that subshell is gone, right? Whereas with a group command, these all run in your current shell. So if you're setting variables and you want to retain them, you definitely want to use a group command. If you want to make sure that you're not sharing variables, you want to make sure you want to use a subshell there. When you do a group command, it's very important that you have spaces next to the braces, as well as the trailing semicolon there. Otherwise, bash, when it's parsing your command, it won't know whether you mean brace expansion or a group command, and it'll assume brace expansion. So always use those spaces there. And I'll show you brace expansion in a little bit. But here we can see an example of this where we have, we're making sure that x, the variable, is unset. And then inside a subshell, we're going to set it and echo it. And then we're going to echo it outside of the subshell. So we get it echoed from the inside. And then outside, we get nothing. So echo just returns a new line. Why? Because when that subshell died, so did x. X was locally bound inside that subshell. So if we wanted to make sure we retain that assignment, we use a group command instead. And then we get hello outside of the subshell because nothing was lost once we exited that. Here's an example of another situation you might want to use either a subshell or a command group. Echo B, echo A sort, right? So we expect AB, but we get BA. Why? It's because echo B, this whole thing is done and over with before we echo A and pipe that to sort. Right? So we want to bring them together. We can use either way, right? So if we do it in a subshell, then we get the correct output. This is because we're basically concatenating in sequence everything that's run inside that subshell before we feed it in as input to the next command in the pipeline. So if you have several commands that you need to perform some operation on like that as output to input through a pipeline, you definitely want to group them together. Otherwise, you're just going to end up losing whatever ran first. This is a little bit of an ugly example, but this is just to show that when you're launching subshells, you actually are spawning new bash instances. So each of those $parens is a new subshell, and that's why we have this process tree where bash keeps spawning itself inside just to run a PS on itself. The $, by the way, that's a special variable, special parameter that just signifies the PID of your current shell, the process ID. And quick warning about backticks. I hate them. You should too. They do the same thing as the $parens, but nesting them gets very ugly very quick. That works fine. But in all honesty, when I first wrote this, I tried to determine how many backslashes I need, and I ended up just needing to guess and check. So I really recommend avoiding those. They're ugly anyway. And one special case that you can do here, actually, there's no command inside this subshell. This will actually take the contents of the file that I'm pointing to, in this case, OS release, and it'll interpolate that directly on the command line for me, which can be useful in limited circumstances, but you got to be careful there, right? If you do some big file with a bunch of commands in it or some special business going on, you could get weird results, right? But this is basically a poor man's cat. Right, I'm just catting that file through echo. Echo cannot cat a file. Echo can only return things that you specified on the command line. So here I'm actually taking that file, putting it on the command line, and then having echo return that to me. And since it's quoted, it retains all the new lines and everything. But otherwise, this is just doing the same thing a cat would do. So this is a useless example of this, but you can see where it could be useful if you're actually doing something important. So we've already kind of touched on redirection, and I assume most of you are familiar with redirection if you're here. But this is just ways to write two files, append to them, take input from them, or take the output of one command as the input to another. Right? And this is what makes Unix shells so powerful to begin with, is that we can have our programs do the work for us. Right? We can have a grep select the text that we need and put that into the program that needs that text so that we don't have to go around copy and pasting it. Right, we can have those programs copy and paste for us. So using these redirects, or maybe a special case of how redirects are working, is command and process substitution. The former basically doing what we just saw with OS release, where we interpolated directly on the command line. So it'll run the command list and replace it directly in the command line as it stands with the output of whatever that command gave. And then process substitution takes that output and puts it into a named pipe with a file descriptor. Right? So this is a way to have something act like a file that's actually a command that you're running. And the file's contents are the output of that command, or the input too. Right? You can do either way there with the arrows going different ways. Both of those run in subshells, but that's not usually important when you're doing this because you're not trying to set variables in those. You're trying to build a command line or build input for something else. And for parameters, we have the variables, which we're familiar with at the bottom, name equals string. Always be sure not to have spaces next to that equal sign. Otherwise, it will not be treated as an assignment. It'll just be treated as 3 words, which might do something, might not. Depends if the first one also happens to be a command, right? We have our positional parameters up top, and those are set from the arguments that were passed. So anytime you write a command, you have the command and then all your flags and arguments. Each of those elements, each of those words gets put into sequentially these positional parameters. When you get above 9, you have to use the curly braces there. Otherwise, it will actually just take $1 and then add a 0 to the end of it. Special parameters, we saw a couple of them already. I can't really go through them here, but they have all sorts of neat stuff in them. And with parameters, when you actually use them with a $, this is called expansion. It takes the value of it and replaces the name with its contents, right? Just like we were doing with that command substitution, replacing it directly in line, right? And so these allow you to do lots of neat stuff, and these are POSIX too. You can use these in just bin sh. You don't need bash for it, right? So this will run anywhere. This has been around forever. But it allows you to do things like specify default values, right? So you can't always rely on your users to properly give the input that you ask for, to properly give you the right command line options and stuff. So if there is a sane default, you can ensure it here. You can ensure that you error out on things. Or the plus is actually an interesting case where you can have an alternate value, which means if the variable is defined we return something else. So a few examples of that, I guess, real quick, would just be if we have, here's our parameter, and we want to make it empty, right? This is set now, but it's also empty. So if I try to just echo it normally, it's going to give me nothing, right? But if I want to say a default value instead, if it's empty, right, now it's going to return default, right? So this could be, for instance, a file path or something, and the user fails to specify it. Instead of default here, right, I could say something like home, right? So this way we can have a same default for what path I'm supposed to store something in. I know home is always going to be writable by that user, right? So if they fail to specify it, I can use a default value. Now I just did that, right? And we got the value, but it's not stored in param, right? We haven't actually edited that variable. If we want to do that, we can replace that with the assignment default value, right? So that did the same thing here as we had here, except it actually assigned that variable now. So if I unset param, we can show one more difference with that one. Right, so this will return the right thing here when it's unset, but if we actually made it equal to nothing, we're no longer going to get that. So that little colon that was in the first way that I did it, that treats emptiness as if it were unset. Usually you don't care about that distinction, so usually you're going to use the colon, because if it's empty somehow, you still don't have a default value, you still don't have what you need, so you're going to want to rely on that default. You can take substrings out, right, offset, length. This is probably pretty familiar to people. So if we have a parameter and its value is race car, if we go in an offset of 3 and take a length of 2, right, we're going to get EC there. Right, if we just go in a length of 3, an offset of 3 and don't specify the length, we get the rest, and it's ecar. Right. The interesting ones for me are the removal from left and right edge. These are extremely useful. The example that I'm going to show you here will be just to take my path variable, right? So just a simple path variable, but let's say I want to look at that path variable without the first element, right? So I'm going to get rid of everything, and this is a pattern, right? So I have star colon. So anything up to a colon, right? So that's going to grab this, and I'm going to remove it from the left edge, right? So now I'm just getting this string returned when I echo that. Sorry, moving around there. Right, so this is pretty powerful stuff because you can also, that's just a single match. We can double it up and make it a greedy match. Right, and now we just have the last one. It took star everything up until the last colon it could find from the left edge. And we can also do the opposite if we want to take it from the right edge, except obviously the direction is reversed. Right, so here I'm just chopping off user games off the end of it. Right, so this is an easy way to take a variable that has some value and not return the whole value, only return the important part. Cut out the whole first part of the URL, things like this, right? It's a quick and dirty way to get the information that you need, and it doesn't modify your variable. So you're not losing any information, you're just using partial information. We can also do indirection, listing, and length. We can pull all of those things out from the variables. We can list names matching a certain prefix. That one's pretty cool. If you have a big script or project, if you put a certain prefix on all of your variables, it makes it really easy to call them all up at once using the bang character there, right? So you can say, show me all of the variables that are, my project underscore whatever, right? It'll show you all of those at once, just the names of them, right? The one right above that, the indirect expansion. So what I mean by that is if param equals parade, that's one variable. Parade equals long, that's another variable, right? When I do bang param, it actually expands that to the value of parade. right? So it gives you long. It's an indirect expansion. It's like a pointer. So you can do some rather complex things with that. We can list the keys in an array, which is great if you want to iterate over them in a for loop or something like that. And we can also get the length of a string or an array. The length of an array would be the number of elements. We can do simple pattern substitution. These aren't regular expressions. Again, it's the same kind of pattern that we've been seeing elsewhere. 1/ is replace once. / is greedy, replace as many as you can. Right? So race car, if we're replacing C question mark, so C followed by some character, right? That's going to just replace the first CE and give us rat car with our replacement string T. And then if we do the /, we're going to get ratter, right? We're going to replace CE and then CA. They don't need to match the same thing. Both of them match the pattern C question mark. And then we can bound that to an edge or the other edge if we want to make sure that we're working in one direction or the other for our single matches. Arrays are available in Bash, but not in the POSIX shell. This is one of the features, I think, that makes it worth using Bash when you can. A lot of people are kind of purists about if you have to write a shell script, you should use SH because it's portable, it's POSIX. But honestly, these days, Bash is almost everywhere. So if you know that you're not going to need to run this somewhere that Bash isn't going to be, you may as well write it in Bash, in my opinion. And arrays are a great feature that you get for that because it's a more complex data structure and you can do very interesting things here, right? So to show a few, we'll make an array, right? And then I'll just use declare real quick to show its contents. So here are the contents of the array in a format that you could use. You could paste this in and just make the new array again, right? So index 0 equals the word 0 and so forth. We can add to an array with plus equals. So here we're adding one element, 4 and beyond. Right, so we can see, it's wrapping around there, but we can see that we have 5 elements now, 0 through 4. And we can do some interesting things here. Right, so this is the same parameter expansion we just saw. We're going to substitute all spaces with an underscore, right, because we often hate spaces when we're working on the command line. So this is actually reassigning array based on the value of array after it goes through that expansion. So when we look at it now, 3 and more used to have spaces. It now has underscores. We can pull out part of the array, and this is operating on elements now instead of characters like it was. So don't get confused there because we can operate inside the values of those elements like we just saw with the spaces being replaced with substitutions, but when we're talking about pulling out things, we're no longer taking out substrings. We're actually working on the array elements. So here I'm starting at the second element, and I'm taking 3. So we can see 0 is now 2, right? Before we had 0 was 0, 1 was 1, right? So we got rid of the first 2 elements that way. And we can list the indices, 0, 1, and 2. Right, which we just saw here. We have 0, 1, and 2. Right, so we could quickly iterate on that if we needed to. And in Bash 4 and above, we have associative arrays, which means instead of a numeric index, you have a key value store, essentially. It's like a simple Perl hash. Arithmetic, we can do all sorts of math at the shell as long as it doesn't involve floating point, sorry. If you need floating point, there's actually a guy, CFA Johnson, who wrote a Bash script, Bash function that can implement it. But if you're going to do any kind of serious math in Bash, you should think twice. It's not going to be the fastest way to do that. But we can do all the simple things that we would need to do, like increment or decrement a variable. Putting it before or after makes it affect the value of that variable then or after the rest of the operations. And then we have all of the normal operations you would expect there, from subtraction, addition, to things like logical or and and. And we can do comparisons, right? And here, if we put a $sign before it, then that also allows us to interpolate it, right? So we can say, give me the result of 3 plus 4, and it echoes 7, right? Otherwise, if I run it without the $sign, we don't get any result. It has success or failure. And here, that's actually determined whether based on whether it's 0 or not. So 0 is a failure if that's all that's left. Anything else is a success. But you don't normally use it that way. Normally, you would be doing something like a comparison there. All right, so here we see that is a success. But if we did the other way around, that's going to be a failure, right? So you can use this as a simple way to test anything comparable like that as well. Brace expansion is really fun stuff because you can generate arbitrary words. The suffix and prefix, they are optional, but anything that's directly adjacent to your brace expansion will be repeated with each thing that's expanded from that. So to give you an example of this, because it's probably confusing to look at there, here I have a couple of nested brace expansions, right? So bash in this instance, this is actually my prefix, and then this is a whole series of nested brace expansions. Sorry about the moving around there. And so when we echo that, each time it expands one of those, it gives a new word that combines the prefix with the next thing that you have in that brace expansion. So this is actually all of the words in the dictionary that's in user shared dict that happens to begin with bash, right? And I just compress those into a brace expansion format. So you can do some interesting things with that. You can do some trivial things like that, like if we want to do man, right, we can run it that way and learn about the man utility, or we could be silly and run it like this, right? If you have an empty element in your brace expansion, it just doesn't add anything, but it adds the new word anyway, right? So that does the same thing. And we can do more interesting things. This is what you would need to do in bash 3 to generate a list of percentages that are going up by 5, right? We use one brace expansion as a prefix to another, and then we also have a % sign as a suffix. In bash 4, we can actually use an iterator inside the the brace expansion. So here we're just telling it to count from 10 to 55 in units of 5, and then add a % sign to each one of them, right? So we can build a whole set of inputs really easily, perhaps for a for loop, for instance, just by doing brace expansion on some values that we need to expand. It also works on letters, right? So if your name happens to be Amy, this is a really easy way to save that. And by easy, I mean long, complicated, and obtuse. And of course, man. And one of the most important things that you can do is writing functions. Even if I'm writing a full script, I always want to break it down into functions because this gives you smaller units that you can work with and chain together in more predictable ways, and it allows you to write your code more programmatically and make it more easily maintainable looking forward. The other nice thing you can get from functions is with redirections built into the function, that actually stays with that function. So when you define it with the redirection, for instance, you could have a function that always throws out all of the standard error output from whatever commands you're running. So if the user is not supposed to see the error output from any of these things that you're running inside your function, you can have that discarded permanently every time they run that function, or every time some script runs that function. So a couple quick examples of functions, right? These aren't necessarily useful in and of themselves other than as demonstrations. But if we have a function words, right, and we see that this takes a compound command. Notice I don't have any curly braces here. You don't need them to have a function. The compound command in this case is actually just the for loop, right? So this is just defining the function, right? So now I have it in memory. I can show it like that if I wanted to see what was going on. And if I want to run it, right, I can say words 1, 2, and it's just for each word, it's echoing word, right, which is going to put each word on its own line. So this would be a quick way that I could test to make sure that my quoting is working how I expect, right? 3, 4, they do end up on the same line, right? So it's just a simple function that can do that kind of thing for you. We can get a little bit more fancy here and reverse some characters, right? We have a negative index here, the -1 in parentheses by car list. So that's actually a relatively recent feature in Bash. Before, there's a more convoluted way that you could do it. But just to show that, 1, 2, 3, right? So it's just taking each of those words and it's reversing all of the characters. For a slightly more complicated example, Google has a great Python script called memtop that is very popular at my work in the support department. Right, so we define that, and I just wrote kind of a cheap, quick implementation of that in a bash function here, and it just gives me a nice sorted output of my most memory hogging applications. Not surprisingly, the browser is on top. And one of the things that I'm most excited about here, that I'll get to in the last few seconds, is session portability. So you've been seeing me use this declare built-in, right? And that just returns the values in a declarative method that would you could directly put that into a shell. And that's all that I'm doing here. I'm actually interpolating that either if I want to run a function that I have in my current session as root or on another host, right? I can do this with sudo or with SSH, and it actually takes everything that I'm declaring there, it sources it on the other side, and then I can run whatever I need. So as an example, if I tried running sudo bash-c memtop, right, we just saw memtop worked, memtop command not found. Why? Because memtop is only something that's defined in my current shell, my current session. So if I want that to work, what I'm actually going to do, is I'm going to put a declaration in there, right? So that's going to interpolate the whole definition of memtop and then run it as root. So you can put any number of things in here that you have in your current shell, and it's declare-f for functions and declare-p for parameters like arrays or variables or anything else that you have. So with that, it becomes very powerful because you can do all of your development locally in your current session, get a whole bunch of things set up that normally die when you close your laptop or whatever, but you can have them directly exported to a remote host or into a root shell, whereas normally it would have been much trickier because you would have to write a whole script, make sure that script lives on that remote host, all those kinds of things. And the old adage is that a good sysadmin is lazy, and I happen to be very lazy, and I'm incredibly lazy about making sure that I have files on other hosts. I don't like worrying about that. So I just do it this way. And with that, I think I just ran out of time. So I do have examples that I used in the slides and some links, so please download the slides. If you have any questions or anything, I'll probably be lingering around outside for a few minutes. Thank you very much.